Indirect measurement. It's really just like a fancy word for we're going to have two similar triangles. We're going to set up a proportion and solve. You've actually already done this. The only difference between this is you have to be able to read words in order to like label them. And I don't really know what's going on in this picture, why this is happening, but it is what it is. So basically, we read the word problem. We label what the word problem says. We use a proportion and we solve. The last problem, you're going to have to like actually draw the picture out. But these, first two, the picture's drawn for you and you just have to label it. There's two types of pictures that you'll see, and that's why I made those the ones that I draw out because, well, just to make sure you know how to draw them and you're not drawing them incorrectly. But okay, so find the height of the Eiffel Tower. Jasmine places a mirror 500 meters away from the tower. Then she positions herself as shown. So it's like mirror here, she's standing here. She can see the top of the Eiffel Tower in the mirror, which shockingly this actually works. Then she positions herself as shown at the top of the tower. Okay, let's read what all. So 1.8 meters off the ground. So she's standing 3 meters from the mirror. Her eyes are 1.8 meters. So this is 1.8. She's standing 3 meters, and then she's 500 meters away from here. How tall is the Eiffel Tower? So it's basically you just like look through all the numbers. Make sure that it's not giving you numbers that you don't need. All right, there's multiple ways to set this up correctly, but the way I like to do it is x over. So this is one triangle, here's the other triangle. The two heights are x and 1.8, so they're going to go in one ratio. And then 500 is on the same triangle as x. 3 and 1.8 are on the same triangle. So just, make sure they're on the same level. If you did 1.8 over x, that's fine. Just put 500 on the bottom if you do that, and you can flip it. All right, we cross multiply. We solve 3x 500 times 1.8. is 900. So the Eiffel Tower is 300 meters tall. Okay, so that's the one type. It'll be like a mirror. On Delta Math, you'll see problems like this. There's a mirror. And then the second type of problem is this type of problem right here. Sean is at a position marked X and wants to find the height of the tower shown. So it's like he's standing here and he sees the top of the flagpole and the top of the tower like all in a direct line. Okay, the flagpole is known to be 18 feet tall. The flagpole is 40 feet away from the 54-foot tall tower. All right, so 40 is like here to here. How far is Sean from the flagpole? All right. Oh, yeah, so I remember that I should have changed the wording on this. So we're going to do this. He does not want to find. Sean is at a position marked X. There we go. And then he does not want to find the height of the flagpole. I think I changed this to make it more like the one that you will see later on. So that's why it's like this. But these are like, remember the corresponding triangle, the corresponding angle triangles? These are these types of... Sure. The little triangle, x over 18. Well, actually, I've set these up differently this entire time, so I might as well continue to set it up the same way. You can set it up x over 18 if you'd like. But I'm going to do x over this large triangle. So we've got little triangle that's x and 18. We've got bigger triangle that has 54 on the bottom. And you're looking for this side, but you don't actually know the length of that side. You just know that part of it's 40 and part of it's x. So we can call it x plus 40. We actually did a problem like this on Thursday. So x over x plus 40, there are multiple ways to set this up. So if you set it up differently and get the same answer, that means you've set it up correctly. And then 18 over 54. You can do one of two things. You can just go ahead and cross multiply, or you could simplify that x over 54 to make the number smaller, which why not? Let's do it. So 18 over 54 simplifies to 1/3, which you guys can't see that, but It does. So that's one way to look at it. Simplify it to 1/3. X over x plus 40 equals 1/3. And then when you cross multiply, it makes things a lot easier. If you don't cross multiply, you're going to have to distribute that 18, which is fine, but I'd rather not. 3x equals x plus 40. Subtract x on both sides. 2x equals 40. Divide by 2x is 20. So we just figured out that he is 20 feet away from the base. But like the reason I worded this problem this way is one, so you could see the difference between like the small triangle and the little and the big triangle. And then two, you may end up having like x plus a number to be able to solve this. Okay, because it will not work if you just do x over 18 equals 40 over 54. Or, you know, x over 40 equals 18 over 54. You're not going to get the right answer. All right, last one. Look at us. We're cruising right through. So Mr. Drysdale is 6 feet tall. At 3 p.m., the shadow of a flagpole measures 85 feet. Okay. Let's see. So let's put the ground first. And then let's put Mr. Drysdale standing right here. And he's 6 feet tall. There we go. And then there's a flagpole. Measures 80. That's a gigantic flagpole. Oh my gosh. That was probably a little too much. But, you know, it is what it is. 85 feet, 6 feet. It's obviously not drawn to scale. It says that he stands 75 feet from the flagpole so that the edge of the shadow meets the flagpole's shadow. Okay, so what does that mean? So his shadow is the same, ends at the same point as the flagpole's shadow. So let's make this actually go over his head. Make it look, you know, reasonable. Oh. So let's make it like this. His shadow and the flagpole. So this is like the, you know, the sun up here. Ooh, it's so bright. And then the shadow goes this way. So here's the sun, flagpole. His shadow is ends at the same point as the flagpole's shadow. Find the height of the flagpoles to the nearest. Find the height of. In the shadow. Y'all, I can't read, so that's a struggle. First period always gets me. This whole thing is 85. He stands 75 feet from the flagpole. Okay, there we go. And we're looking for the height. There, now I can read. So let's make sure I did this correctly. I actually had this. Oh yeah, that's right. So there we go. I drew it a lot. It was a lot prettier last year. So yeah, 6 feet tall. We're looking for the height. We know that he's 75 feet from the flagpole. We know that this whole thing is 85. So, you know that this is 10 right here. Oh, not X. 10. So you can write that. And you've got your like baby triangle. That's 10 on the bottom. And the height is, you know, 6 feet. Then you've got your bigger triangle. That's 85 and X. So the thing that I really want to point out here is the fact that you aren't putting 75 into your proportion. Because that was like a thing that a lot of people were messing up on. You're not putting 85 in your proportion. Or 75. See, it's right there, but it's really just to show you this length. 85 is what goes in the proportion. Alright, so 10, the base is 10 over 85. Equals 6 over X. Make sure 85 and X are in the same, you know, both on the bottom. 10 and 6 are both on the top. You can simplify that if you want, but you don't have to. 10X equals 85 times 6. 510. So X is going to be 51. Why would we do it to the nearest meter? I mean, I guess we can convert it to meters, but I don't know if I really want to. So it's 51 feet, and I guess that's about 17 meters. Probably like more like 16 meters. But you're not going to have to convert to meters. We're not working on that right now. So let's just say it's 51 feet and move on. But yeah, so that's like the gist of it, how to solve these.